Hello friends, welcome back. Let's look at this interesting example related to polynomials and the zeros of a polynomial. If c comma d are zeros of x square plus ax plus b and a comma b are zeros of x square plus cx plus d, then find the values of a, b, c and d. So how will we proceed with this problem? Is we just know the relation between the zeros and the coefficients of the polynomial, quadratic polynomial to be specific. So let's put down that equation. We will say x square plus ax plus b and x square plus cx plus d are the two polynomials. So we have been given that c comma d are zeros here, and in the second case a comma b are zeros. Now I know that the sum of c and d is nothing but minus of b by a, that's equal to minus a, and also I know the product of zeros is equal to c by a, that's equal to b. Similarly, if I apply the same logic here, the sum of zeros is equal to minus of b by a, that is minus c, and the product of zeros a into b equal to d. Now we have to leverage these four conditions, whatever we have, to find out the values of a, b and c and d. For that I will start with first the products. I will write a, b equal to d and b is nothing but equal to cdb. So can I say b equal to cd? So can I say here a into cd equal to d? That will give me ac into d equal to d. dd cancels. I'll have ac equal to 1. That's a good beginning. So we got a into c equal to 1. That's our first equation. Okay. Now once we got AC equal to 1, how can we use that? Now let's go back to the other equations we have. A plus b equal to minus c and c plus d equal to minus a. So if you try to equate b, if you try to equate c from both of them, let us see what happens. I will have a plus c plus d is equal to, from here, nothing but equal to a plus b plus c. How we got it? From c plus d equal to minus a, we got a plus c plus d, and a plus b equal to minus c, we got a plus b plus c equal to 0. So equating both of them, let me just write it down here. This gives me a plus c plus d equal to 0, and this gives me a plus b plus c is equal to 0. Now we equate both of them. You will have a, c, cancelling it out, and we'll have b equal to d. Now let's take this b equal to d and substitute in a b equal to d. We'll have a into 1, a into b equal to b, because b equal to d, that gives me a equal to 1. So if a equal to 1, then c is equal to 1 by a, that's equal to 1. So we got a equal to 1, we got c equal to 1. Now the next equation what we will use is a plus b equal to minus c. So I know a is 1 plus b equal to minus 1, that will give me b equal to minus 2. So I know b equal to minus 2 now, but I also know b equal to d, therefore I can write d equal to minus 2. So let me summarize that again. We have x square plus ax plus b, given that the zeros are c and d, and for x square plus cx plus d, given the zeros are a and b. So we know c plus d is minus a, cd is b. Similarly, in the second polynomial, we know a plus b is minus c and ab equal to d. Now, if you try to leverage the conditions here, we get a equal to c equal to 1 and b equal to minus 2 and d is equal to minus 2. So that's an interesting problem which I thought I will share it with you. Okay, so I'll catch you again with another interesting example. Thanks for your time. Bye for now.